Hello, my amazing students. This is Mrs. A, and we are starting our COVID-19 videos here. I'm going to try to make this experience just as easy as I possibly can for you. I think a lot of you are going to like going online because you're going to get the material much earlier than you get it in the classroom. So some of you that are real go-getters are going to love this. And some of you might not, but we'll see. I'm going to do the best I can to make it a lot of fun and easy to do so that we can get through this without too much problem. Okay, so we are on 6.4, which is on normal approximation of the binomial. So what I'm going to do is I'm going to go through the PowerPoint with you and lead you into a couple of things that I want you to do. So here we go. So here's your PowerPoint that is on your blackboard for this section, the normal approximation to the binomial distribution, and we are looking at objective 7 in our textbook, which is use the normal approximation to compute probabilities for a binomial variable. Now we did the binomial distribution back in chapter 5, and now we're talking about being able to use the normal, the standard normal curve to find the probability of a binomial distribution. And when a few conditions are met, we can do this. So here we have your first little getaway assignment. Now, in order to be able to record your attendance and your participation, you're going to need to take some notes, and you're going to take pictures of these notes and send them to me. So the first thing you're going to do is you're going to go to your resources on your Connect Math. Go to your Connect Math, sign in, go to resources, go to videos, go to chapter 6, section 4, and then the normal approximation of the binomial distribution. Watch the lecture video and take careful notes. I think that's about 6 minutes long. And then you're going to eventually turn those in for participation. After watching the lecture video, watch the second video, marked exercise, select technologies. That's the name of the video. It's right next to this one. There are only 2 under this section. And then again, taking notes. Now, you can take all of these notes on the same picture, on the same page, but just draw a line in between and use your titles, keep things neat so I know which part you're taking notes of. So you're going to go do that first, and then you're going to come back to this video and you're going to finish it up. So I'm going to save the rest of this until you have gone break away, go do the other, and then come back and do the rest of this video. So just pause this one and then come back. So this page here is characteristics of a binomial distribution. And so we're going to, as we go through this slide, we're going to learn what are the characteristics of a binomial distribution. This is a review for you. Because we need to know if something is a binomial distribution so that we can then decide whether we can use the normal approximation to the binomial distribution. If we don't know it's a binomial distribution, then we won't know if we can use the normal to approximate it. So it says, recall that a binomial distribution has the following characteristics. There must be a blank number of trials. Okay, so a fixed number of trials in a binomial distribution. The outcome of each trial must be independent. Okay, each experiment can have only how many outcomes? The answer is 2 outcomes, or outcomes that can be reduced to 2 outcomes. Okay, binomial, bi meaning 2, right? So when there's just a success or a failure, That is binomial. Okay, the probability of a success must remain the same for each trial. Okay, so when those conditions are met, we have a binomial distribution, and the mean of a binomial distribution is n times p. P is the probability of success, remember. And then 1 minus p could be designated q, and q is the number of failures, or 1 minus the number of successes. And remember, n was counting the number of trials. Okay, so the fixed number of trials was the n. Okay, so when can we use the normal distribution to approximate the binomial? So here are the conditions for being able to use the normal to approximate the binomial. When n is large, that is 100 or more, the blank distribution, okay, and the answer to that one is the normal distribution, can sometimes be used to approximate the binomial distribution. When the probability of success is close to 0.5, now that's important, so I made it red. That's one of our conditions. When the probability of success, oops, I hit my table, is close to 0.5, then the shape of the binomial distribution is approximately normal. Statisticians agree, as a rule of thumb, that the normal distribution should be used only when n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Okay, so that's usually only going to be true when our n is very, very large, or our probability of success is close to 0.5. Okay, so the larger n gets, the more apt we are to qualify for the n times the p to be greater than 5 and the n times the q to be greater than 5. So then it says, however, and now we have a continuity correction that's coming in here. A continuity correction should also be used when employing the normal distribution to represent a discrete distribution. Now remember, binomial is discrete. So we're using the normal distribution to represent a binomial distribution. And remember, discrete means it's only going to, there's nothing in between the values. Okay, it's like countable for discrete. So when we're using the normal, we have to use a continuity correction to correct for the binomial being discrete. Okay, so that a continuity correction means that for any specific value of x, say 8, the boundaries of x in the binomial distribution, in this case 7.5 to 8.5, so we're going a half on each side of the 8, must be used. So that is just to compensate for the fact that we're trying to estimate a discrete distribution with a normal or a continuous distribution. Okay, so here, this is a summary of how to do this continuity correction here. It says if we're finding the probability that x is equal to a certain value, then when we're using the normal, we're going to use a range of values, because remember, the normal is continuous and the binomial is discrete. So if we're looking for p is equal to x equals something, then we're going to go a half on each side. So a plus 0.5, a minus 0.5. If the probability of x is greater than or equal to a, then it's going to be greater than this one right here. But look at this. X is greater than this one right here. So basically, if you flipped this around, it would say this, okay? Now let's skip down here to this one. This one down here is also a less than or equal to. So the less than or equal to here is going to be this part right here. Okay, so if you remember that, the less than or equal to is the same as the right-hand side of the original. And then, if we're using just the greater than, look what happens here. Okay, it's not equal to, it's greater than. So basically, it's a plus the 0.5. And then if it's the less than, it's less than a minus the 0.5. So it's moving a half a step in the direction of the inequality. So it takes a little bit to learn those, but that comes with practice. For all cases, the mean is n times p, and the standard deviation is the square root of npq. And then we have these conditions right here. np must be greater than or equal to 5, and nq must be greater than or equal to 5 for us to even be able to use this normal approximation to the binomial. So now here is the procedure. Once we've decided that we are able to use it, now we have our procedure to figure out the steps here. So step 1 in the procedure of approximating the binomial distribution with the normal curve is check to see whether the normal approximation can be used. Step 2 is find the mean and the standard deviation. Step 3 is write the problem in probability notation using x. Step 4 is rewrite the problem by using the continuity correction factor and showing the corresponding area under the normal distribution. Step 5 is find the corresponding z values. And step 6 is find the solution, or you could state find the probability. So those are our steps. And now we have our first example. So this one comes out of the guided student notes that are in your Connect Math resources. These are given you by your author here. Guided student notes. So college students often make up a substantial portion of the population of college cities and towns. State College, Pennsylvania, ranks first with 71.1% of its population made up of college students. What is the probability that in a random sample of 150 people from State College, more than 50 are not college students? Okay, so basically State College is the city name. That's a little bit confusing. Okay, State College, Pennsylvania is the name of the city. So how many out of 150 people taken from the city, more than 50 are not college students? Okay, so up here in the little box I put the important parts of the problem. So here's step 1. Check if the normal approximation can be used. All right, so remember that P represents the probability that a person in the college is not a college student, because that's what we're trying to check here. More than 50 are not. So we have to redefine our definition of success here. Okay, so then it says, next it says, thus, if the probability that a citizen is a college student is 0.7111, the probability that a citizen is not a college student is 0.289. So our P, which is our probability of success, is 0.289, and our Q, which is our probability of failure, is 0.711. Now we got to see, are we going to make the cut here? Because we have a large P, remember, N, we have 150 people that are being sampled. So we might make it over the 5 here. So let's look at the next one. Okay, so N is 150 and N is greater than 100. So that was our first qualification. And then P is 0.289, and N times P is going to be 43.35, which is greater than 5. Okay, and then N times Q is going to be 150 times 0.7, what was the other one? 711, 0.711. So they just did 150 minus the number that were not college students, and they got this one. So either way, you could have just used the NQ, but they did it that way, and it works. And so both of these quantities are greater than 5. So the normal distribution can be used, and step 1 is a success. So then we go to step 2. Write the probability notation that models the problem. So here, remember, we're trying to find out that more than 50 are not college students. Okay, so we're going to designate that. What is the probability that in a random sample of 150 people from State College, Pennsylvania, more than 50 are not college students? So the probability that more than 50 are not college students is the probability that X is greater than 50, because X represents our success variable, and not college students is our measure of success. Therefore, X is greater than 50 would model our probability statement for us. So now we go to step 3, find the mean and the standard deviation of the distribution. And when the mean is N times P, and that gives us 43.35, and the standard deviation is NPQ square rooted. So we multiply all of those together, take the square root, and we get 5.552. Okay, so then rewrite the problem using the continuity correction factor. So remember, our X is greater than 50 was our binomial thought. So now, since we're going from a binomial, a discrete probability distribution, to the normal, which is a continuous, we must use the correct continuity correction. So remember, if we have X is greater than a number, we go back here to this one right here. X is greater than a number, then we say X is greater than that number plus 0.5. So we're moving 0.5 more in the direction of the inequality. And then we go back here. So they have the X is greater than 50 plus the 0.5. X is greater than 50.5 with our continuity correction. And then find the corresponding Z values. So we're going to take our 50.5, which is our X, minus our mean, divided by our standard deviation to get our Z-score. And we get 1.287 or 1.29. That is our Z-score. And that is the Z-score that we can go straight to the normal, standard normal table with. Okay, so find the probability. Use the table or technology to find the probability. If X is greater than 50.5, then that is the Z-score. That was the Z-score, I forgot it already, 1.29, and we get the probability is 0.0985 based on the rounded value of Z. Okay, so you could have gone either to the table or to your technology. So if we're going to find the, here we're finding the probability, which is the same thing as the area to the right. Okay, so here we go. Let's look at our calculator. Okay, so here is my calculator screen, and I put in the 1.29. That is the Z-score. Here, see if I can get the light on it there. I'm using the CDF because this is a continuum. This is not one value. This is like going cumulative. 1.29 to 10,000. Oops, I think I lost a zero in there. I should have had one more zero. But anyway, it was a big number. and comma 0, comma 1, because that was the z-score. And I get the 0.0985, which is what I was supposed to get. And we have one more slide here. And this is your last screen. This is your participation segment here. Okay, it says we have another little video that is just 4 minutes long. Go to the below link, just copy it and paste it on your browser. And this video that is short and excellent video for 6.4. And Larry Green is a great little YouTuber, and he loves statistics. So you're going to work through this example in your notes, keeping it for future assignments. Take a picture of these notes and send it to me. That is your, so you're going to take the notes. Now, I don't want a picture of your computer screen. I want a picture of your notes that you've taken so that you have some good notes to come back and be able to do something on homework or quizzes later on. Good notes on how to do the normal approximation to the binomial. And that is the end of our lesson. Okay, so we're done with 6.4 and done with chapter 6. So tomorrow I'm going to be doing a video for you on just how we're going to do this whole coronavirus online thing and how I'm going to make sure that you get all the segments of your course. I'm going to come up with a schedule for you. So this is all going to be okay. We're going to get this thing done. We're going to have fun doing it. So I want you to try to keep up, though. I don't want you to get behind, because it's just very important that we finish they're not giving us any extra time to finish the course. But the nice thing is an online course moves faster, just because you're not having to come and listen to my lectures. You can listen to my lectures anytime you want to, and you can do your participation anytime you want to, as long as you stay ahead of my schedule. So you're going to go now to make sure you've got your notes. You're going to take a picture of your notes. You're going to send them to me at my email. And then you're going to make sure that up in the little subject line, you're going to give me your name and which section of notes these are. Then you're going to go to the Blackboard and go over to the dialogue section and look for a dialogue for 6.4. Once you have finished the, basically you check in with, I'm done with my video and my PowerPoint and my participation, and then you come back and check in under 6.4 when you have done the homework and any quizzes that should be done to finish that up. So basically I'm just having you check in so that you will get an idea of where you are in the pack of the students. That's part of your participation, is checking in. But you just check in and say, hey, I'm done with the video and the PowerPoint, and I have sent my notes to you. And then I just know to go and look for your notes. And then you come back later and you go back to the same section and you say, and now I've done my homework online and I've done the quiz and I'm ready to move on. So this is going to work. I think it's going to be fine. All right, this is Mrs. A. May God bless your day.